This is section 8.4, systems of nonlinear equations. Very similar to 8.1, systems of linear equations. We're still using the substitution method or the addition method, but now our equations are nonlinear. So in this one, they're actually telling us to use the substitution method. So we will simply take this and plug it in for y in the first equation. So since our second equation is already solved for y, we don't have to manipulate either of the equations any bit, and we can just plug it in. So x plus y equals 2 is my first equation, but I'm substituting what y is equal to for my second equation in there. Okay, I have a quadratic equation. I'm going to go ahead and get it in standard form by setting it equal to 0. I can factor this to solve for x. Oops. That would be a minus 5 to get that negative 30. Okay, I factor it, and then I set each of these factors equal to 0. And I solve, and I get x equals positive 5 and x equals negative 6. But I'm not done, right? Because remember, when we're talking about the solutions to systems, we're talking about what point do these graphs intersect? And they could not intersect at all, right? But if I'm talking about what point that they intersect, well, here it's giving me two x's. That means that, okay, I'm intersecting at 2 points, but I only have a portion of my points. So I need to go ahead and plug in each x into either one of the equations. It doesn't matter. I'm going to use that first one. So when x is negative 6, y is 8. So that would be one ordered pair, one point where these graphs intersect. And then I go ahead and plug in the other one. And right after I get the other variable, so in this case, I had my x's first, and when I solve for my y, I immediately write the ordered pair, and I do that because in the past, I have mixed up which x goes with which y. So that just sort of clarifies it for me. So when I go up here to write my answer and give the solution set, I don't accidentally pair negative 6 with negative 3. And that's our answer. So notice that we took the same approach, right? If you're a little bit lost on the substitution method, I would definitely check out the video for 8.1 because we break it down much more. But this is taking that same approach. Okay, so here they're telling us to solve the system of equations by the substitution method. So again, we're just going to substitute one equation into the other. Both of these are equal to y. So I can take this from my first equation, and since it's equal to y, I can replace y in my second equation. And I'm doing that so that I have an equation with just one variable, and I can solve for that one variable like we did in the last problem, and then go ahead and plug it in to solve for the other missing variable. So if I was to plug that in, I'd have x squared plus 7x minus 1 equals negative x squared minus 3x minus 13. I see x squared in the mix, so I'm like, okay, I'm going to try to get this in the standard form of a quadratic equation. Okay, I have it in standard form. Now, remember, when I go to factor this, my very first question is always, is there a GCF? If there is a common factor, I want to pull out the greatest common factor, right? So 2 can go into all of them, so I'm going to factor out a 2 to make this a little bit simpler to factor. And then I can go ahead and continue to factor. I set each of my factors that include a variable equal to 0. And I get x equals -2 and x equals, sorry, that's supposed to be a 2, and x equals -3. So remember, I still have to go and plug it in, right? So I'm going to plug it in this first one right here. Y equals -2 squared plus 7 times -2 minus 1. Okay, so I'm going to go ahead and write my ordered pair right away so I don't mess up which goes with which. And then I go ahead and plug in -3. Punch that in a calculator. I paused the video to calculate, so I'm not just doing this in my head. And make sure again that these are matched correctly. So when I plugged in -3 for x, I got -13 for y. All right, so there's my answer. So if you get multiple values for x, or let's say you got y first, then you still need to plug each of them in there to find the corresponding missing variable. All right. So they tell us to use the addition method on this one. It makes sense because right there, that's going to eliminate my y variables. In this previous one, if I would have added these two equations together, let me choose a different color. Yes, these would have been eliminated, the x squared, but I still would have just a plain x variable in there. And so I still would have x and y, and I couldn't solve for that. I need an equation that just has forms of x or just has forms of y. So here that works out because when I add these two equations, it completely gets rid of all of my y's. And so I can add these together. I get 2x squared equals 2. Continue to solve for x. We get x squared equals 1. I'm going to do the square root. So I could just get x. But when I do the square root of 1, remember that that is going to be positive or -1, right? Because 1 squared is 1, but -1 squared is also 1. So the square root of 1 can be positive or -1. Be careful of that because if you just put +1, then when you go to plug it in to find the matching y, you're only going to get that one set. So I'm going to go ahead and plug it in. First, I'm just going to do +1. Okay, so I get 1 plus y squared equals 101. Continue to solve for y. I get y squared equals 100. Again, I'm going to take the square root of both sides. I get just y on the left side, which was my goal, right? But on the right side, I get plus or minus 10. Because remember, -10 squared would also give me positive 100. So notice that this one input of 1 gave me positive 10, but it also gave me negative 10. So that actually gives us two ordered pairs from just that one input that of positive 1. Okay, but that didn't even take care of the fact that we're also going to do negative 1, right? Because that was also one of our x values. So plug that in as well. Negative 1 squared is 1. So we see that the math is starting to look exactly the same. Yeah, y equals plus or minus 10. So again, from that one input of negative 1, I have positive 10, but then also at negative 1, I'll have negative 10. So you actually have 4 points here that match up. So on the graph, I have negative 1, positive 10, and then I have negative 1, negative 10. I have positive 1, positive 10, and positive 1, negative 10. So with this one, you get 4 answers. And that means that there are 4 points, these 4 points, where they actually intersect. They want us to solve this one using the addition method, but notice that if we were to add these two equations, nothing would be eliminated, right? So we have to manipulate this a little bit just so that we can eliminate either the x's or all of the y's. So I'm actually going to choose the x's to eliminate. So that's what my focus is on. So I'm going to multiply the top by 5, the top equation, and then the bottom equation, I'm going to multiply it by negative 2. Now I'm doing that so that I can have opposite coefficients. When I multiply 2x squared by 5, I'm going to get positive 10x squared. And when I multiply 5x squared by negative 2, I'll get negative 10x squared. And then we could add those together and eliminate that. I do have to multiply it though by every single part of that equation. So I'm going to pause it real quick, do that math, and then come back. Okay, so I went ahead and I multiplied each term on both sides of the first equation by 5. And then the second equation, I multiplied each term on both sides of the equation by negative 2. And these are my 2 equations that I have now. It's the same exact equations as before, except we manipulated it a bit so that we can eliminate. So we eliminate the x's, that worked out great. And then okay, now let's go ahead and start solving for y. I'm going to move over here to the right. Square root of both sides to get that y isolated. And remember, the square root of positive 4 would be positive or negative 2. Okay, so now I get y first. That doesn't change anything. I'm still going to go back into the equation, one of the equations. I'm going to just choose the first one. I'm going to choose the first original equation. I'm going to plug in positive 2. So 2 times, oops, and not into x. That's my y, so be careful of that. I was about to plug it in for my x. So 2x squared minus 4 times positive 2 squared equals negative 8. And then from there, I would go ahead and solve for the x that correlates with the positive 2. This is 4, so negative 4 times 4 is negative 16. Okay, now notice we have x squared equals 4. So that's telling me that I'm going to get two different outputs, because in this case we did the input as a y. So x equals positive or negative 2. So that means that when my y is positive 2, and be careful here because I keep wanting to put in for the x, but when my y is positive 2, I have positive 2 as my x, but I also have a point at negative 2, 2. Okay, so that's only for this when we plugged in 2 for y. But now we have to plug in negative 2, right? So 2x squared minus 4 times negative 2 squared equals negative 8. And let's see how that math is going to go. This is positive 4. So looking very similar. And same old, right? We end up with x equals positive and negative 2. Okay, so remember, this is what that means. When I plug in negative 2 for my y, I get positive 2 for my x, but I also get negative 2. So this ends up with 4 points as well, right? My solution set would be all of them. I have positive 2, 2, positive 2, negative 2, negative 2, positive 2, and negative 2, negative 2. Be careful, because that can definitely be confusing. But that means that on my graph, I have negative 2, oops, I put negative 2, 0 as one of the points. That's not one of the points. Negative 2, negative 2, positive 2, negative 2, negative 2. Positive 2, positive 2, positive 2, negative 2. So that would be all the places that these two nonlinear equations intersect. Okay, they want us to use the addition method. So be careful here, because obviously that second equation has something else going on that we hadn't seen before, right? That's okay though, because our y squared is sort of isolated in each of the equations. So we can go ahead and make the top one negative. So I'm just going to multiply everything by negative 1. And I get, this is my first equation now, I get minus x squared minus y squared equals negative 41. Okay, and then with that, that eliminates my y squared. Okay, so now I have negative x squared plus x minus 6 squared. You're not going to want to touch that just yet. Just leave it be. And then we can go ahead and simplify this. X minus 6 times x minus 6, what's that going to take us to? That's going to be plus x squared minus 6x minus 6x plus 36 equals 24. Subtract 36 from both sides. Continue to solve for x, and we get x equals 5. But remember, that's only part of our answer, right? Now we have to plug it in. So 5 squared, I'm plugging into that first equation to solve for y. I get 25 plus y squared equals 41. Subtract 25 from both sides. Square root. Square root of 16 will be positive or negative 4. So that means when I have an input of 5, I get positive 4, but I also get negative 4. So this gives me 2 ordered pairs as my solution set. So hopefully you're seeing by now that although the math does get a bit more challenging than 8.1, the approach is the same. So this one tells us to use the method of our choice. I'm going to use the substitution method because it seems easiest to just rewrite the second equation, solve for x, and then I can substitute that 21 minus y in for x in the first equation. So remember 21 minus y squared is 21 minus y, that's a tongue twister, times 21 minus y. Okay, and then we drop down the rest of that equation. Set it equal to 0. It ends up zeroing out that 441 on the left side as well. I have negative 42y plus 3y squared equals 0. And I'm going to factor out 3y and then set each of these factors equal to 0. So I'm going to come up to their top right corner. 3y equals 0. So I have y equals 0. And then negative 14 plus y equals 0 gives me y equals 14. Okay, so now I'm going to plug each of those in to one of the equations. I'm going to use the second one since it's the simpler one. X plus 0 equals 21. So x equals 21 when y is 0. That's my first ordered pair. And then when y is 14, x is 7. So there's my second ordered pair. Again, this one tells me to use the method of my choice. I see opposites right there, so I'm going to go ahead and add them together. I'm going to bring it down here first. X cubed plus y equals 0, and then negative 3x squared minus y equals 0. I can add these like terms together. They're opposites of each other, and then I'm left with just x variables, but I cannot combine those unlike terms because one is x cubed and one is x squared. So we would just write it like that. I'm going to factor out an x squared. Get x minus 3 equals 0. And then I'm going to set each of these factors equal to 0. So x squared equals 0. That would give me x equals 0. And then x minus 3 equals 0 would give me x equals 3. Okay, now we're going to take each of those and plug it back into the original equation, either one, right? I'm going to go ahead and use that first one. So 0 cubed plus y equals 0. So when x is 0, y is also 0. That's one ordered pair. When x is 3, y is negative 27. So that is my second ordered pair. Hopefully you see the pattern going on here, and not so much the pattern, but just the approach of it. We still say, okay, how do I get the value of my x or my y variable, and in this case, the values of that variable, and then plugging it in and then solving for the missing variable. Okay, so this word problem says a system for tracking ships indicates that a ship lies on a path described by 6y squared minus x squared equals 5. The process is repeated and the ship is found to lie on a path described by 6x squared minus y equals 5. If it is known that the ship is located in the first quadrant of the coordinate system, so real quick with our coordinate system, this is my first quadrant. And in my first quadrant, I have positive x's and positive y's. Every single ordered pair you'll find in the first quadrant, I have to move right with my x's so it's positive, and I have to move up with my y's so it's positive. And so it says that it's in the first quadrant of the coordinate system, and it wants to know the exact location. Well, we're trying to find what point lies on both of these paths, right? And so that would be the solution to this solution set. So let's bring our equations down here. Now remember, I'm trying to either eliminate my x variables or all my y variables, right? This one's a little bit tricky because it's 6y squared, right? And then at the bottom it's 6x squared. So I can go ahead and multiply either of them by 6 and it'll eliminate the other one. So I'm going to multiply. First, I'm going to rewrite this one so that my x's are first and then my y's. That one I wrote exactly the same. So I'm going to multiply the top by 6 so that I can eliminate my x's. That's what I'm going for. So now I have negative 6x squared plus 36y squared equals 30. And at the bottom, I'm just going to write it exactly the way it is. So I eliminate my x's. That was my point, right? I have 35y squared equals 35. Solving for y, I get y squared equals 1. Square root that to get just y by itself. Square root it on the other side, and I get y equals positive or negative 1. Now, usually I would plug in both positive 1 for y and solve for the x, and then negative 1 for y. But because I know in this word problem they said that the ordered pair is in the first quadrant, I know that I can go ahead and throw out negative 1. So I'm only going to use y equals positive 1 because that's the only one that will be in this portion of the quadrant. A negative y is going to be somewhere down here or down there. Okay, so I'm going to take my first equation, plug in positive 1, and now we're solving for x. So 1 squared is 1, 6 times 1 is just 6. Divide by negative 1 to get a positive x squared. and I get x equals positive or negative 1. But again, if I utilize that negative 1, it's going to put me on the left side of the y-axis, and it wouldn't be in quadrant 1 anymore. So I'm only going to utilize the positive. So I have positive 1, and that is the exact location of my ship.